Welcome to High Performance Attics and Walls, a WISE educational program brought to you by Console. This course is a WISE educational program funded by the California Energy Commission's Electric Program Investment Charge Program. The producer of this interactive training, Building Media Incorporated, is a registered provider with the American Institute of Architects Continuing Education Systems. This course is approved for 1 credit hour. At the end of this course, you will be able to cite the drivers of energy efficiency policy, including California's Title 24 Building Energy Efficiency Standards. State the requirements of the HPA, HPW, prescriptive, and performance options. Compare the difference and relation between HPA, HPW, and Quality Insulation Installation, QII. Evaluate installation cost considerations. Anticipate proposed changes to and impacts from the 2019 Title 24 codes. Understand WISE installer training and how to schedule training. Let's review the drivers of energy efficiency policy in California. In the state of California, energy efficiency standards and codes have been steadily developing since at least 1978. As part of energy efficiency, high-performance attics and high-performance walls became prescriptive requirements in California's 2016 Building Energy Efficiency Standards, and these codes went into effect on January 1, 2017. The 2019 updates are being formed now with proposed changes that will affect California home builders, including increased insulation requirements for attics and walls in some climate zones, as well as removing the solar trade-offs that are allowed in our current code. The most significant changes that took effect on January 1, 2017 are the requirements for high-performance attics, high-performance walls, the setting of a minimum energy factor of 0.82 for tankless water heaters, high-efficacy lighting, and the solar trade-off allowances. There are many benefits to high-performance attics and walls. These include reducing the amount of heat gain and heat loss, thereby reducing heating and cooling loads, improving the performance of HVAC systems by keeping attics cooler, and reducing thermal bridging that occurs through the framing. Title 24 provides 2 compliance paths: prescriptive and performance. For the prescriptive path, you must follow preset specifications based on the climate zone you're building in. The performance method allows you to have an energy analyst approve the building energy design through the use of CEC-approved software. This is an option typically used by production builders. Let's take a look at the specific requirements for high-performance attics. There are very good reasons for requiring the construction of high-performance attics. In the summer, attic temperatures are easily 130 degrees or higher. In most California homes, the HVAC system is located in the attic. In addition, ductwork is typically only insulated to R8. This leads to a total attic heat gain through ducts and equipment for a typical home of close to 1 ton of air conditioning. To comply prescriptively as a high-performance attic, there are 3 options. Option A for vented attics with continuous insulation above the roof deck and ceiling insulation separately above the finished attic ceiling. Option B for vented attics with batt, spray-in insulation with netting, or SPF below the roof deck with ceiling insulation separately above the finished attic ceiling. And Option C for vented attics with no insulation at the roof deck, ceiling insulation separately above the finished attic ceiling, and ducts or air handler equipment in conditioned space that is not the attic. Let's look at each of these options in detail. For option A, insulation is added above the rafters and, for most climate zones, R38 ceiling insulation is used. A radiant barrier is required. When an air gap exists, such as with tile roofs, R6 insulation is required. For roofs with no air gaps, such as asphalt roofs, R8 is required since there is no air gap below the roofing. A nailable base solution can be used to provide an air gap when using asphalt shingles and can be a simple solution for incorporating energy efficiency into your building. Click on the picture to view the detail of this type of solution. This table represents the 2016 Prescriptive Compliance Requirements for Option A. Highlights of the requirements include a ventilated attic, R6 when there is an air gap, R8 when there is no air gap, a radiant barrier, and, for most climate zones beyond the coast, R38 is required above the finished attic ceiling. Click on the table to enlarge. For option B, insulation is added below the roof deck and between the roof rafters. For most climate zones, R38 ceiling insulation must be used above the ceiling lid. A radiant barrier is not required. When an air gap exists, R13 insulation is required, and when no air gap is present, R18 is required. This table represents the 2016 Prescriptive Compliance Requirements for Option B. Highlights of the requirements include a ventilated attic, R13 when there is an air gap, R18 when there is no air gap, no radiant barrier for most climate zones beyond the coast, and R38 above the ceiling lid. Click on the table to enlarge. An unconditioned attic is the worst place you can put the ducts for your air conditioning. Option C requires a ventilated attic and that the air handler and ducts must be in a conditioned space. In most climate zones, a radiant barrier is required, and, depending on the climate zone the building is in, either R30 or R38 must be installed at the ceiling. Click on the picture for detail of ducts in a conditioned space. Here are 3 examples of ducts located in conditioned space. First, ducts located in soffits below the ceiling, such as a drop ceiling. Second, ducts located between the floors. The third, ducts located in boxed trusses that accommodate a duct chase near the attic floor. This table represents the 2016 Prescriptive Compliance Requirements for Option C. Highlights of the requirements include a ventilated attic, R30 ceiling insulation for most areas on or near the coast, and R38 for inland areas. A radiant barrier is required for most climate zones. Click on the table to enlarge. The Performance Compliance option allows you to use an energy analyst to demonstrate a project's compliance. With this method, air sealing is required between the attic and the exterior, and minimum insulation levels are required at the underside of the roof deck. There is no radiant barrier requirement, no required insulation at the ceiling, and no venting requirement. Gable end walls are insulated to the same level as exterior walls. The performance option does not qualify for ducts in conditioned space credit. Builders do have some concerns with the high-performance attic requirements, including the limited data that is available on the long-term impacts to the roof deck, the structural impact of sheathing on loads, nail patterns, and shear, as well as the potential impact to roof deck and shingle warranties. The testing of new roof assemblies for fire rating is both expensive and difficult to time, and the sequencing and production schedules become hard to coordinate and manage. Lastly, personnel must be trained on new construction techniques, and companies must stay current with OSHA requirements for fall protection and work in confined spaces. Now, let's take a look at specific requirements for high-performance walls. Meeting the prescriptive requirements for high-performance walls is required in climate zones 1 through 5 and 8 through 16. Continuous exterior insulation is required, and advanced framing techniques, which will be discussed later in this course, can be used. While there are numerous configuration options, HPW requires a U factor of 0.051. Click on the picture of a detailed view of a high-performance wall assembly. This table details the thermal performance of various wall assemblies using different combinations of framing size, cavity insulation, and exterior sheathing. The cells highlighted in green meet or surpass the U factor of 0.051 needed to comply with the prescriptive requirements for high-performance walls under the 2016 Title 24 Building Code. For instance, a 2x6 16-inch on-center wall with R21 batt insulation and 1 inch of EPS exterior rigid foam board rated at R4 per inch has a U factor of 0.051 and, therefore, meets the definition of a high-performance wall. There can be challenges meeting the requirements with window fenestration when using exterior rigid foam board greater than 1 inch, when the wall plan, with a siding or stucco, extends beyond the maximum offsets available from window manufacturers. There is a solution, however. Wood or insulated bucks can be used that allow the window to sit flush with the exterior wall. The Window and Door Manufacturers Association and the Fenestration Manufacturers Association, along with the Architectural Aluminum Manufacturers Association, detail this solution in publication 500-16. Here are some examples of window bucks, also known as rough opening extension support elements, which can be used to allow the window to sit flush with the exterior wall. Both wood and insulated types are available. Issues can also occur with stucco and continuous insulation. Using the 3-coat method can mean that the thickness of the stucco goes beyond the window spacing. While the 1-coat method is preferred, the 3-coat method is still possible, but specific guidelines must be followed for fastening. The performance method of compliance provides 3 options that can be modeled which will take advantage of the features of high-performance walls, including lower wall U vectors, lower infiltration rates, and meeting the requirements of quality insulation installation. Advanced framing is one of the most cost-effective methods of building used to balance energy code requirements with building code requirements. Advanced framing is more than just increasing stud spacing from 16-inch on center to 24-inch on center. The goal is to reduce framing factors from 25% to below 15%. Framing factor is the percentage of the exterior wall that is not cavity insulation. Some techniques used to accomplish this include using insulated headers, single top plates where feasible, ladder blocking for interior corners, California corners, two stud corners, reducing window framing, and stacked framing. Let's take a look at these in detail. Using 24-inch on-center spacing is the best way to reduce framing percentage and lower material costs. In addition, this technique improves the overall assembly U factor. Using energy-efficient headers, which replaces framing materials with extra cavity space, improves the U factor of headers and reduces the amount of wood use. In addition, a related technique is to leave out window and door headers on non-load-bearing walls. In stacked or inline framing, all structural members are stacked from the structural floor foundation to the studs, then to the rafters, creating a direct load path. In addition to cost savings, this allows more room for insulation and also lessens the number of thermal bridges from the outside to the inside of the wall envelope. There are less pathways for cold or heat transfer via the wooden studs. Advanced framing two-stud corner junctions include ladder blocking, drywall clips, or an alternative means of supporting interior or exterior finished materials. This allows insulation at corner intersections and reduces the amount of wall framing members needed. Traditionally, framed corners trap an airspace within the framing. California corner construction eliminates this problem and makes it easier to insulate the exterior envelope, reduces thermal transmittance across these areas, and helps with overall energy performance. In addition, material costs are no higher and less labor is required with this technique. To really tackle the problem of thermal bridging, the double stud and staggered methods can be used to interrupt the process by creating a thermal break. This method is not as deep as a double wall, but more like two independent walls sharing common plates. Structural insulated panels, or SIPs, are another step towards high-performance building for residential construction. The SIPs are constructed with an insulating foam core sandwiched between two structural facings. SIPs create minimal thermal bridging and reduce labor costs, but do not require more pre-planning for electrical and equipment needs. Builders have some concerns with the high-performance walls requirements, including the increased cost of 2x6 walls, increased insulation, and the need for specialized equipment. Window manufacturers must retool to accommodate thicker walls, and trades are still unfamiliar with the required flashing details. In addition, the additional 2-inch protrusion into side yard clearance could require lot line adjustments, and into conditioned areas could result in loss of conditioned space. The California Energy Commission's CEC optional standard for the way that insulation should be installed in a home is referred to as High Quality Insulation Installation, QII. The primary goal of QII and the requirement for meeting the standard is to make sure that the insulated framing areas resist thermal bridging of the assembly, separating conditioned from unconditioned space. QII is now being considered as a mandatory requirement for the next code cycle. Insulation performs best in a sealed cavity. If the house isn't properly sealed, cold can easily transfer through the rafters and studs, and, in some cases, condensation can form in the drywall. Wall stud cavities should be sealed to provide a substantially airtight envelope. Plumbing and wiring and other penetrations through top or bottom plates or exterior sheathing should be sealed, and minimally expansive foam should be used to seal all gaps in the air barrier. When combined properly, air sealing and insulation work well together to stop heated and cooled air from escaping the building envelope. How are high-performance attics and walls related to QII? While both work towards the goal of a better-performing assembly and reducing the energy use of the home, they come from different sources. QII is driven by poor insulation installations that have essentially reduced the R value and performance of insulation products. QII, with its inspection component, is aimed at ensuring insulation is installed correctly to obtain the full benefit of the product. HPA and HPW are driven by the goal of reducing energy use in residential buildings. One of the biggest challenges for builders and owners is determining the cost-effectiveness of various compliance features. The most cost-effective approach can vary by climate zone. These two graphs represent the potential cost-effectiveness of features in Coastal Climate Zone 6 and Central Valley Climate Zone 10. As you can see, there is no easy answer. However, insulation plays an important role in meeting compliance options cost-effectively. The best path often includes trade-offs. Energy modeling is one way to help determine the cost-effectiveness for various features. An energy modeler, consultant, or analyst can assist with choosing the compliance method that meets your project's goals and with the calculations that must be submitted to show that the proposed structure meets the minimum level of energy efficiency and Title 24 requirements. Looking ahead to the 2019 code, here are a few changes that are expected. The current code allows trade-offs for some prescriptive measures if solar is installed. In 2019, those trade-offs for solar will likely go away, and all prescriptive requirements, whether solar is installed or not, will have to be met. In addition, compliance with currently proposed 2019 standards will require homes to meet a minimum efficiency performance target before the addition of storage and renewables. With more stringency, it will become a challenge to meet the 2019 code with 2x4 walls, HVAC tweaking, or super-insulated attics for many climate zones. The new code also looks to increase prescriptive R and U values. The ROESE team provides training on all the techniques mentioned in this course and can help your company minimize installation costs while learning successful installation strategies and gaining an understanding of QII. Courses are provided free of charge, on demand, online, on-site, and via webinar. This has been High Performance Attics and Walls, a WISE educational program brought to you by the California Energy Commission's Electric Program Investment Charge Program. For more information, please use the contact information on the screen.